To add a curved poly model in scene, you need to have a curved poly component active on one of your game objects. As we have seen, this can be done with Game Objects tools from Curved Poly Editor. Or, it can be done by creating a new curved poly with Create Other, Curved Poly, New Curved Poly. Together with the curved poly component, a mesh renderer is added, used to render the mesh generated by curved poly. There is also an hidden mesh filter added. The mesh filter is hidden since you cannot assign a mesh to it. Curved poly will use it to assign the proper mesh to your model. The mesh filter is still accessible by code in case you need it. The curved poly component has three important parameters. The first one is the asset used, which may be unassigned, or none, meaning that the model is stored in scene, rather than being stored in a shared asset. For instance, we can drag and drop here a curved poly asset. And we can remove the asset again to remove the reference. The second parameter is the Levels of Details table, or LODS table. That is the table which describes the level of details which can be used on the model. LODS table can be customized, and we are going to show this in a later section, but for the rest of this presentation we are going to keep using the default LODS asset. And the third parameter here is the exact load chosen, which must be one of the LODS available in the table. As you can easily check on your own, changing the LODS will upgrade the model with a different amount of polygons. The component has also some advanced tools in the output options sections. In order to understand this section, keep in mind that curved poly models are not exactly visible in scene. What you can see here is a regular mesh which is generated by curved poly. These output options define how that mesh is generated. The first control is the mesh mode. This defines which mesh data are going to be generated from the model. By default it should be set to default plus tangents. In version 1.0 of curved poly, tangents were not generated on the model, so if you select default you are going to miss tangents. With no UV the mesh will be missing both U's and tangents. In version 1.1 we had added an option to generate automatically of 2, but recently Unity has added some similar automation which integrates well with curved poly, and you don't need this anymore. Use this if you are using curved poly on a Unity version previous to 2019 I say, and you need of 2. Talking about integration with other plugins and tools, you should consider to use mesh references in some situations. Indeed, by default curved poly generates meshes at runtime. Since the meshes are generated at runtime, there is no way to feed them to other plugins or components you use in the editor, but you can do that only using scripts. In case you can't do your own scripts, mesh references are your best option. When we press on Generate Meshes Ref from Load, we are asked to place a new asset somewhere in the project. The asset will contain a set of regular Unity meshes, one for each LODS, which can be used everywhere in the project. While the link between the meshes ref asset and the curved poly component is active, any update to the model will be applied to the mesh matching the assigned load, and curved poly will keep using the meshes in the asset even in play mode, upgrading them when necessary. There is also the option to update all the meshes at once. It is also possible to remove the mesh ref from the curved poly component. In this case the meshes ref assets will keep being in the project, but the meshes will not be updated anymore. Then, below here, we have the colliders options. This is interesting only in case you are using a collider on the same game object, and you want to make changes to the curved poly asset at runtime. In this case, curved poly can indeed update the parameters of the collider at runtime. For mesh colliders, the collider mesh will be assigned by choosing one of the available LODS on the same model. So, playing with LODS we can have a very detailed model with a more simplified shape in its collider. Both the model and the collider mesh can be updated if you change the asset on the model at runtime. Again, below colliders we have a few mesh actions. We have already seen that we can rest a model to curved poly default material here in one click. We can also remove the curved poly component. In this case a visible mesh filter will replace the model, with a mesh assigned which depends on the last load which were selected on the model before removing curved poly component. Before removing a curved poly, or before detaching a mesh's ref, it may be useful to recompute normals. What happens here is that curved poly uses Unity Recompute normals algorithm to change the normals. This is usually a downgrade, since curved poly normals are generated on curved poly data, rather than mesh data, and therefore they are more precise. That said, we may have specific situations in which Unity normals are better than curved poly normals. Keep in mind that any change to the model will use again curved poly algorithms to compute normals, so this is an action which makes sense only if you are going to remove curved poly component or remove a mesh ref asset from it, because in that cases you will get a mesh which is not affected by curved poly anymore. Okay, now, let's say we have already opened the editor and the dedicated inspector, and shown in the previous section. From Game Objects Tools, we can overview a few more tools related to a curved poly components. These sections were previously part of the main curved poly inspector, but we moved them here to make it a bit more simple. Here you can find a few statistics about the model, and about the mesh generated from the model. There is also the option to overview the levels of detail used on the model, which can be changed here, but keep in mind that any change here will affect any model using the same LoDS asset. We also suggest to avoid making changes on the original default LoDS asset, where you can create a new custom LoDS, or clone the default one if you need to make changes. Last but not least, we have a data compression section. Here you can work on parameters which define how data is compressed in curved poly models. Indeed, vertices, normals and U's can be saved with different resolution. Increasing the resolution, increase the precision but also increases the size of the asset. Take for instance the vertex precision. This allows you to define the resolution used to save vertices coordinates, where the default milli stays for 1 milli part of the unit, which for most real curved poly models is pretty much enough. The default settings are usually fair enough, but in case you feel you need more precision, you can refer to the inline docs which explain better the meaning of each parameter.